core operating system group. For the last 7 years, I've been leading a cross company effort around standardization for commercial video delivery on the internet. And so we're going to talk about that, but first I want to see if anyone here is familiar with a few concepts and kind of gauge what you understand already. How many people here are familiar with the common encryption spec, ISO MPEG common encryption spec? So we got a couple of people there. Or the DASH spec, the dynamic adaptive streaming over HTTP. W3C, HTML5 encrypted media extensions and media source extensions. There are a few more people there. We're going to be talking about that. We're going to be talking about the concept of the web and sort of what some people view as a paradox about using DRM in the web. So first I'm going to talk a little bit about commercial media and the internet. And this is a topic that can cause, as we'll see, a lot of unpleasant conversations, let's say, because people feel so strongly about digital rights management. But then we'll talk about the advances that have been made in DRM-interoperable encoding. And this was the first thing that we did at Microsoft, was to try to solve the problem of digital rights management on the web by making DRM interoperable. And then we'll get to the meat of the subject as it relates to this group, and that is cross-platform enhanced content protection and the role that that plays in actually making commercial video more interoperable on the web. And this is this is an interesting aspect of what we're going to discuss, because it turns out that the work that you're doing in the very low levels in the stack is actually freeing up commercial video to be much more portable and interoperable at higher levels. And it's kind of interesting how that's played out. And then we'll talk about the implications for commercial video and implications for the web. And to me, this is the most important part of the presentation. It's trying to understand the kind of strategic inflection point that we're right in the middle of, that you typically don't realize when you're in the middle of an inflection point like that it's happening. So I'd like to start by going into the subject of the paradox of commerce and the web. And this was first, and I think best articulated by a WIPO report, which is the United Nations organization, when they, in 2003, when they were discussing what essentially the internet has done to digital assets. Because when you want to be able to monetize a piece of content, digital asset, you need to be able to maintain some scarcity of that content on behalf of the rights holder, but then the business is to make it available. So this seems to produce a paradox. If you're going to distribute content on the web, you want to make it widely available, but then on the other hand, you don't want everyone to copy it, otherwise you're unable to monetize your investment. And actually, over the last 7 years, this problem actually was solved through open standards. And before we get to the topic of actually how that was solved, I want to talk a little bit about the misconceptions about DRM. These first two quotes, which are, basically are accurate and correct, but they miss the point because they essentially assume that the purpose of DRM is to make content uncopyable in an absolute sense, which is a level of protection that even Fort Knox cannot afford for gold, if they have gold in Fort Knox anymore, I don't know. But in fact, this conversation became so difficult that in 2007, David Pakman basically said, if we're still having this conversation in 5 years' time, I'm out of here, I'm done. So 5 years later, we worked with Google and Netflix almost to the day and brought the conversation to the one organization where we thought the dialogue, level of the dialogue would reach a new peak and go on endlessly, the W3C. And the response we got was, this is unethical. That's the whole email, by the way. We sent this email and said, hey, we have this great idea. Here's how DRM can be used inside a browser, and well, so much for constructive dialogue. But now every browser, including Firefox and Chrome and Safari and Edge and Internet Explorer, supports these extensions. So I want to say something about why this was viewed as an intractable problem. Up until 7 or 8 years ago, the whole conversation about DRM was between people who felt passionately that it was evil and should not be allowed on the web, and content holders who placed unreasonable expectations on what DRM can do. But in truth, DRM is just intended to make, to enforce authorization, but not to the point where it makes the experience unpleasant to a consumer. So this really was about interoperability and mobility of experience. And the solution, we felt 7 years ago, was a twofold solution. One was to make commercial video, live and on-demand commercial video content that people have invested a great sum of money in making, that they want to be able to monetize, to make it interoperable across platforms. And the second was to create an application framework which is also interoperable across platforms. And both of these things have happened in the last 7 years. So look, I'm going to spend a little bit of time talking about the actual encoding of the content, since it seemed like only a handful of people in the audience are aware of the digital rights management common encryption spec. I'll talk a little bit about how we created that at Microsoft 7 years ago and how it became an ISO MPEG standard. So the first thing to understand about DRM is it requires that a cloud service is able to control or manage what the device is doing, or the client in the device, in terms of rendering the content. So unless there was going to be one single cloud service for the entire planet, right, this would require you to have multiple cloud services to be able to interoperate, to manage the same content. This came out of a research project that I did at Microsoft 7 years ago, where we determined that for video in particular, DRM would not go away in the foreseeable future. It at least will be here for 10 years. And there will be between 2 and 10 different DRMs in use in the world. And if that's true, then that creates an enormous friction. You have all these walled gardens, which is very similar to what we saw in 1993 with the web. You know, you dial in, you get what AOL would provide, a kind of a view of the internet, and you didn't have interoperability. So we felt there needed to be a way for different video services to interoperate. Without going into a whole tutorial on how DRM works, there are different parts of a DRM system. There's a licensing regime, because as I said, if your client is controlled by a cloud service, then that means there's a license component. And that's extremely difficult to standardize licensing terms. So that's not going to happen. And this is why there wouldn't be this one monolithic DRM for the planet. You can't really standardize the entire stack. You can standardize components. Rights expression language, there was an attempt to standardize that in MPEG Rel 21, which collapsed under its own weight because of the tight integration between rights expression language and business models. You know, different kinds of, everyone wanted to load that expression language with every pet business model that they had. Key acquisition protocols are tied to hook IP. Hook IP is just basically some patented technology that you get when you license something. It proves that you actually have the license. It might be elliptic curve parameters or some other software that you've gotten when you license the technology. A little bit easier to standardize, but very difficult overall to try to get everyone to use the same key acquisition protocol. So the one thing that we felt could easily be standardized was the actual encryption and the signaling within the stream for live or on-demand video, the various mechanisms for acquiring a key from different DRMs. So that's what was standardized in 2012 in ISO-MPEG, and it also was released in combination with a interoperable adaptive streaming specification, which actually goes far beyond adaptive streaming. It's an entire presentation language, media presentation language. It works the same way as HLS or smooth streaming, both of which have very similar constructs, but it's an ISO-MPEG standard. And I think that that topic alone is a very interesting topic because it represents the ability to say, here are alternate languages, here are alternate video angles for a sporting event. It's a overall generalized interface, and there is a standards organization as well as an industry organization with about 90 companies developing the Dash profiles to be used for live and on-demand video streaming on the internet. We'll get to that in a second. But the important thing here was that having come up with a way for you to have a single catalog of video that can be consumed by different devices with different DRMs, so Widevine, which is the DRM that's used in Android, PlayReady, which is the DRM used both in Windows but also in a lot of embedded devices, smart TVs and set-top boxes, and so on. All of the major DRM providers now support this common encryption mechanism with a common signaling, and the same live video stream can be consumed by different DRM technologies. That was the first half of the problem. Make the content interoperable. The second half was a little more challenging. And I wrote a paper at Microsoft 6 years ago, and I said, well, here's all the pieces we would have to have in place. One of them is, how do you bake all of this into HTML5? So as I mentioned, Google and Microsoft and Netflix submitted a proposal to the W3C for how both Dash, or adaptive streaming, as well as EME, the DRM signaling, could be incorporated directly into HTML5 without plugins. And I want to talk a bit about how that relates to enhanced content protection and what's happening in the industry right now as it relates to your own activities. So let's talk about the specifications that we've mentioned. There are two specifications that extensions to HTML5 that have been proposed. One is the encrypted media extensions and the media source extensions. And the media source extensions are what make Dash work inside of HTML5. So you have a manifest, you can write a JavaScript application, and it will basically parse the Dash manifest and be able to push in different bitrate video streams into the buffer. The common encryption spec corresponds to the EME spec. So you can have the same video stream going to an HTML5 browser that supports EME and MSE, and it will determine which key system you're using, and it can support multiple key systems. So the same content that's being captured on a Safari iOS device in principle could be consumed on your Xbox or on a smart TV. And when you bring all these together, the EME MSE specs from the W3C and the common encryption and Dash specs from the MPEG organization, you now have the ability to, in principle, construct mobility of experience of commercial video delivery. And I think this is an important point, but what's really important is understanding the role of enhanced content protection and security in actually making this extremely portable. And to understand that, we need to spend a little time talking about how EME is intended to work. So in EME, you'll have a HTML JavaScript application, and its role is to select the DRM, the key system that is available on that piece of hardware. And the browser extends that HTML5 to allow JavaScript handling. So the browser's only job here is to extend that functionality. There's no DRM functionality in the browser per se. And in fact, there's no DRM functionality in the JavaScript application. It's just providing a means for communicating to the DRM system, which is called a content decryption module in the EME spec. Now, a content decryption module basically is exposing the methods and attributes defined by EME to the JavaScript application, but it's transparent to that application if the CDM is really in the browser or if it's deep in the hardware. And that's going to become an important point to understand in a minute. And so contrary to a common misconception, the reason why we got the kind of response we did from many people, to be honest, in the W3C about bringing a DRM mechanism to HTML5 was the assumption we were actually putting DRM inside of the browser. What we're actually doing is allowing for DRM functionality to be exposed to an application where the DRM functionality is going to naturally be close to the hardware. So let's talk about enhanced content protection and the trust layers that are exposed. Generally speaking, from the cloud DRM service perspective, you can't trust the JavaScript application because you could just easily modify it. And the browser also cannot be trusted because, let's be honest, it's a code injection program. I mean, that's the whole point of it. So from a security perspective, the browser shouldn't be trusted. And the portion of the CDM that's in the browser for enhanced content protection, especially when you're talking about 4K content, next generation, ultra HD, high frame rate content, the CDM itself that's in the browser shouldn't be trusted. And so this means that the DRM itself must be trusted, and the ECP requirements are actually causing, the enhanced content protection requirements are causing the DRM components to be pushed down in the hardware and actually enabling the app to be more portable because it's forcing segregation of the HTML, JavaScript, and browser away from anything having to do with content protection. And this depends critically on the ability for the browser to be able to be truly portable in the sense of how it talks to the DRM that's in the hardware. So when we realized that several years ago, this is when, well, around 2013, we realized there was a need to standardize the interface to the DRM that might be in the platform. So I published a specification called the CDMI specification. It's available online. And this was the basis of the open CDM work that was done by Fraunhofer Focus in Berlin, which was incorporated in your OPT project here. And it basically, it works like this. You have a browser, a web view of some kind. It could be a hosted native app. In fact, it generally will be a hosted native app and not a true browser. And it has some platform-specific interface to a media engine because you're generally doing the decode in hardware. You're doing the decrypt in hardware as well. The browser generally is in a embedded device is not going to be doing decode in software. And so you take the DRM device software that is as close to the metal as possible, and it actually produces the objects that are used, that are defined in the encrypted media extension specification, which actually have no DRM components. They're just objects and attributes that enable a JavaScript application to interact with the DRM system that's in the hardware. So it creates that, and then it uses remote procedure calls to project that object into any application that might be residing in the untrusted area of the ecosystem. So you're basically, on your device, you're running the DRM in the T, and you're using remote procedure calls to project this object, which itself has no keys or any other protected content, into the application that's residing in the application space. So by doing it in this way, it's possible for different DRM systems to reside on different pieces of hardware, and the same browser on different pieces of hardware be able to use the same interface to talk to those DRMs. And in fact, I don't know if I can talk publicly about this, the implementations of this that have been done for set-top boxes, but this is being done today. So you've got one set-top box using one DRM, another set-top box using another, and the browser itself, or the user agent that's residing on top of that, is using the exact same interface to capture the same objects to talk to that DRM. The difference between the DRMs then simply becomes what license server they talk to, what cloud service they're interacting with, and they're consuming the exact same content using the exact same decryption algorithms. Now this is, it's kind of, there's a as above, so below thing going on here, because you're actually having to solve problems very close to the hardware to make interoperability happen at an application layer. So let's talk about one last piece of this. We felt that typically these web applications will not be actually running in a browser, but in embedded environments, they're going to be running in hosted web apps or hosted native apps. And these are very important because they can be designed to access system API calls that are not generally exposed from within a browser. So for example, in Windows 10, you can just point to your HTML5 JavaScript application on a web server and produce a native application, and that application can actually access the entire WinRT API set. So you can have live tiles and voice integration. You can integrate to all of the APIs that are exposed to a regular XAML app that might be running on that device. But this is generally true across different platforms. So we developed, Microsoft developed something called Manifold.js. It's an open source project. You can access it online, manifold.js.com. And it works with the W3C Manifest for Web App specification. This is a working draft specification that basically defines a manifest. It says how to build a hosted application on that platform. So it works for Windows, it works for a number of platforms. And it builds a native app when possible, otherwise it does a polyfill using Cordova. How many people here know what Cordova is? Anybody? It's like so it'll extend the HTML, JavaScript to hybrid applications. And this means that you can build an application, you can take your HTML, JavaScript code, and it manifests already exists for your platform. You can develop the application and have it build on all these different, it'll build on Windows, it'll build on iOS, it'll build on Android, it'll build on Windows 8, Chrome OS. There's a whole bunch more. There's a number of set-top box manufacturers that are developing manifests for targeting their devices as well. And the whole point is that by being able to write a standard-based HTML, encrypted media extension, media source extension, web page that'll run in a browser, and then build native applications based on that, targeting all of these embedded devices, you basically have replaced what used to be what people were using Flash and Silverlight for, create a platform for interoperable media delivery. And we believe this is the direction the industry will go over the coming years. So let's talk a little bit about what that means. So what? It's like, I mean, does this matter, and how will it change things? Will it change anything? And I think that I was recently reading a book that came out about 6 months ago, comparing Andy Grove and Steve Jobs and Bill Gates' business strategies. And I was really impressed about what Andy Grove talked about when he talked about strategic inflection points. These are moments when something happens, right? And this has happened a bunch of times in all of your lives. Some of you too young to remember some of the ones I'm going to mention. It's when something happens, and at the time you don't really realize it's a significance until like 5 years later you look back and say, oh, that was significant. And usually it's the people working in the trenches who see these things. So I'm telling you that I've been working in the trenches with a lot of people across the industry, not just at Microsoft, but in media companies across both US and Europe. And we are at an inflection point. There's a very important thing happening. You know, the amount of content that is being streamed today, without all the standardization we're talking about, I can't remember how many thousands of years of video just went by in the time it took me to complete that sentence. I mean, this has become, the internet has become dominated by video. And on top of that, we're now seeing that there will be, by 2020, 15 billion video-enabled embedded devices on the planet. I mean, that's with a B. That's an astonishing transformation of the internet. So let's talk about a couple of inflection points that happened before. This is the internet in 1989. That's 1989 over there. Even though the internet technically could have, you could say the internet was invented with the publication of TCP/IP, it wasn't until AT&T made their source for TCP/IP public that we really saw this high inflection point in the growth of the internet. And at that time, you wouldn't really realize just how significant the internet was going to become. And by 1990, there were 300,000 hosts on the planet. And does anyone know how many websites there were in 1990? Anyone have a guess? There was one website in 1990. So in 1990, Tim Berners-Lee, he reimagined the internet. That's what he did. It was still the internet, but he reimagined it as the web. And you'll notice that by 1992, there were still only 26 websites. They used to fly around, go to research labs with a floppy with links to the 26 websites and say, and here's a little rudimentary browser thing, and say you could, you can see graphs and so on. The reason why it took off was in February of 1993, we had a watershed moment with the introduction of the Mosaic browser. So that by 97, there were well over 1 million websites. So that's an inflection point. And if you were here at 1993, you wouldn't be saying, oh, we're going to have 1 million websites. And I remember seeing the first advertisement in a magazine, which actually gave a URL, and thinking, oh, that's quaint. That's funny. There's a URL. And of course, realizing the significance of these moments and what it actually will mean when you're at that point in time is extremely difficult. So, I use this in a lot of my talks, this 1890 Victorian trading card, where they imagined that this is the future. They came up with ideas about what video would be like, basically wireless, the telephotoscope. And they could not envision television channels and networks and affiliates and commercial breaks. These are the consequences of their ideas, but they couldn't really imagine it because we tend to think we're going to do the same thing in a new way rather than do new things that we hadn't imagined before. And these recent developments that I'm talking about, this ability to have an interface, the CDM interface in the hardware, the ability to do encrypted media extensions, media source extensions, and dash and common encryption, mobility of commercial video delivery, the ability to actually monetize video content. But more importantly, I don't know, anyone have an idea how many different code bases Netflix maintains to have the footprint that they have on devices? Make a order of magnitude guess, anyone? Nope. It's hundreds. The number seems to vary. I keep hearing 500, but then I've heard 700, but it's hundreds. Think of the friction, and also think of all the negotiations you had to do to get on those devices. Now imagine a world where the devices instead are standing up a media engine that supports EME, MSE, and all you have to do is stand up a web page, and now you're doing commercial video delivery. You're a channel. You're a think of the sports channels. Think of all the major football European football teams having their own channel on the internet live, right? That's the consequence of having this kind of capability. They don't have to go out and hire a team of engineers to say, okay, now I'm developing for Android, now I'm developing for Windows, now I'm developing for these smart TVs. They just stand up a web page, right? So that's transformative. That changes everything. So one of the big consequences will be in long tail content. You know, when I say long tail, I'm not talking about, you know, peekaboo cats and guys, you know, falling on their skateboards and so on. I'm talking about content that is actually long tail content that is capable of being monetized. And so what I believe is going to happen is what we have today is legacy content, mainstream content going to cable, satellite, and telco and set-top boxes. That's evolved into online video distributors like Netflix, going to more devices. And they've also had to avoid the wholesale price transfer problem, they've had to go to deliver their own content. But what we're going to see now is we're going to see not only vertical niche content, like I mentioned, sports franchises. There's everything you see in a magazine stand is going to become a channel, but also specialty authorization providers. You know, American Express could bring you travel channels on the internet, that sort of thing. So this is my last slide. The demands for enhanced content protection. I just want to kind of summarize what I believe is happening, and so you have something to take back with you. Coupled with emerging standards, constitute a disruptive innovation for the video industry and for the web. And it is as above as below. It's a very disruptive for embedded devices. We were talking about IoT a few minutes ago. It's the same issue. Things that, big changes in the cloud correspond to big changes in embedded devices. An HTML JavaScript platform for commercial video apps and development methods like Manifold.js allows you to build native apps to lots of different platforms with a single effort, will cause an explosion in long-tail video services. We're going to see, it's going to change the way video is consumed. And in fact, right now we view internet media as an alternate pipe for consuming content we get over cable or so forth. They call it TV everywhere model. That will no longer be the case. It'll become indistinguishable. You'll sit down and you'll watch a live streamed sporting event and you won't remember if this is coming from my cable provider or from a channel that I acquired off the internet. And so that both the internet and commercial video are going to be transformed by this evolution. Thank you very much.
Okay, we're good. Everybody, have a great day. Thanks for coming.